Sharing my screen. So we now live on YouTube. Let me get the presentation. Okay, so we come to the third learning outcome, which I assume is the last learning outcome for this unit. And in today's learning outcome, we have to be able to design a database system. So in the previous tutorial, we introduced the several type of database systems and how this database management system process has to be done. We had a couple of explanation of type of design which has to be implemented, and how entities and attributes related to each other, and especially how the relationship between them work. So for today's session, which we are now required to design them, we will look into details about other topics. So what we need to focus on today is to understand the basic steps which are required for designing a database system. So as you can see, what we have to be doing now is for us to determine the purpose of the system. Then we have to look into the table that we need to add for our system. So also we're going to demonstrate the fields that we need in the tables. Then we're going to identify the fields with unique values. Also, we have to determine the relationship between them and redefine this design. Once all this has to be done, then we have to add data, which means we have to populate our table with by adding data into all the fields in order for us to create the objects. So as we introduced in the last tutorial, we introduced what are entities and attributes and how these are related to each other. So the best way to graphically represent our database management is by using EAPDIM. So a really good software for creating EAPDs is draw.io. So I want you, Adrian, to download this software into your PC, and let me know once you've done it. Okay, 1 second. Have you downloaded them, Adrian?
Yeah.
I'm checking if I have it already on my PC. No, I don't have it. I need to download it as well. Download for Windows. Download this. Okay. So what allows us to do from draw.io, we can now create this these diagrams, which will illustrate, which will explain how the relationship between our entities. So what we want to do now, for example, we can choose blank diagram. Maybe we can go for a blank one. What is this? 1 second. It's asking me to save this. Yeah. Save. Okay. So with draw.io, we can now have our simple we can now create diagrams. So 1 second, let me just entity relationship. Yeah. So we can now create tables. For example, here we put Untitled. And now for each row, we can now populate each row with the student number ID 19222 19223 19224. For example, now we have our diagram. We can now move it around. We can now create another diagram, another table, which will be student name, for example, student name, and we can put Mark Victor Alvin. And now, once we have our table, maybe let's put one more table. Put it here. Couple. And so we can have as much as table as we want, but once we've created our tables, we have to now create our relationship between them. So what we will now choose, we'll now go into we have to now choose our arrows. So our arrows now, they create relationship between them. So we have direct connection, where now we have to put a vector for it. From here, now say connects to this one here. And then we have another one. So now, for example, what we're saying is that in our database management system, by entering the email address, we can now retrieve data regarding the students. So this might look like a hierarchical database management, which I explained in our first tutorial, where we have a root table where our email is going to be our root table, where we can now, by having the email address of someone, we can now retrieve more details regarding this the student. So what we can retrieve by entering his email address, for example, Mark email address is unique@gmail.com. So since he's on number 1, we now know that the email address unique@gmail is assigned to Mark, and his student number starts from 199222. So this with draw.io, we're now able to create loads of entity relationship diagram, depending on the type of diagram that we're going to look into. So entity ERD diagrams are really useful. And also there is a something pretty much similar, but it's be slightly more complex, which is a business process model notation, which are visual property, which they pretty much have the same concept, but they mainly focus on the workflow of visual paradigm. So this software is a Paradigm Online. With this software, it also allows us to create ERD diagrams, but it also gives us more functionality where we can also look into creating different type of diagrams, more related even into business process. So I would recommend draw.io as a really good starting point, where we can now create now pretty much nice diagram. Also, we are able to export these diagrams, where we just simply need to Control-C. We save the ERD diagram, save on to desktop. Let's see if it's been saved now. Also, this diagram has to be exported somehow. 1 second. Export as PDF. Include a copy of the diagram. Export. Save into this device. Okay. So if we now go into downloads, let me just open Google Chrome. Open with Google Chrome. Why is it coming up like this? Anyways. Now, as you can see, we have the representation of our table. Okay. Okay, so with draw.io, we now ready to create this diagram and then save them into our machine. So I recommend to save them as a PDF file, which would be easier for us to read. And this is how we created an hierarchical diagram. So now coming back to our presentation, we can now look into a couple of definitions. So as you can see here, what is an entity relationship diagram? By entity relationship diagram is a graphical representation of an information system that shows the relationship between people, object, places, concept, or even events within the system. So with this ERD is a data modeling technique that can help define business process and can be used as the foundation for relational database. So as I explained, business process model notation, the other software which I was showing, is more useful for business process, but this business process can also be done with ERD diagrams, where we basically have to define like a type of flow chart with a starting point and the end point in order for us to create a really effective strategy. So three main components of ERD are the entities, which are object to concept that can have data stored about them, the relationship between them, between these entities, and the cardinality, which defines the relationship in terms of numbers. So we have already come into looking into, we already created our own table, but from this image, we can see how a table which will be done for a retail shop, for example, would work. So we can now see how these entities, they're related to each other with arrows. So what we can see is that one instance sells. So this is how they communicate. Also, we have to understand the symbols of ERD. So as you saw from what I draw, on the left-hand side, there was a panel with which you were able to between diagrams, between shapes and other stuff. So it's really important to understand what was the purpose of them, because they might look similar, but they will have different functionality. So for example, we can see entity might be used with a rectangle. Weak entry might look like a rectangle, but it has an internal lines. Also attributes and with their own shape. And then there is also arrows that might be depending on what type of relationship. So it could be many to one, or many to many, or even one to one. So depending on the relationship, we're now going to have different types of arrows. Now we have to look into data flow diagram, where my data flow diagram, they simply maps out the flow of information for any process or system. So you basically used to define symbols like rectangle, circles, and arrow, plus short next label to show the data inputs, outputs, storage, points, and the route between each destination. So as we can see, these diagrams are pretty much useful in order for us to define our symbols. So as we can see, this is a quite structured example of how these diagrams work. And here also is the explanation of the symbols, where we already have seen how there are entities, what is the symbol for processing, data storage, and also data flow of how the data flows. Also, we need to, when it comes into design, there are several aspects for this database, and there are several basic design phases which have to be taken into consideration when we're creating our application. So our phases has to integrate their conceptual design review, logical design review, physical, organizational, SQL, SQL, application code, pre-implementation design, and post-implementation. So if we're going to analyze in detail each of them, we can now see that the first one, which is a conceptual design, it simply has the purpose of the review is simply to validate the application concept. So where we can now involve a representation of our statement of purpose, as well as general overview of the desired functionality that will be provided in the application. So what this means is that we're going to conduct as early as possible to determine the overall feasibility of the project. So the project which provide duplicate or inadequate functionality, and the project which are cancelled due to the lack of funds, staffing, planning, user participation. So as we can see, we just use this type of design review just to convalidate the initial concept. Also, there is a logical design, biological design, which is the second phase, which should be conducted with the first one has been as core of the logical data model has been completed, which will happen through a review of all the data elements, description and relationship should now occur with the logical design review, where the scrutinizing, well, we should now scrutinize the following area, which this area has the logical model being truly examined to ensure that all the data is required. And this model, at least, is will have a third normal form. Also, is going to have all the data elements, which are entities and attributes required for our application to be identified. And other important stuff to know is if you have data elements which will have been identified and they also been documented accurately. And also you need to know if the relationship between them has been defined properly. So once we have come into this logical design review, we can now move into the physical design, where the database has now been reviewed in details to ensure that all the proper database parameter settings are ready to go, and then the physical design choice can be made. So what will happen is that the organizational design review will now examine the impact of new application upon the organization from the business and technological representation. Also, we have to consider the design, the structured query and language design review, where the statement by statement review of every SQL statement in the application with an eye towards accuracy and performance. Where in this stage, we should consider several analyses, where these analyses have to now explain for each SQL statement how this production will now work. And every program should be reviewed to validate the inefficient host language. Then there are the last two phases, which are pre-implementation design review, where what happens is that an overall review of the system components prior to the implementation. And for the post-implementation design review, we're now going to determine if the application is meeting the objectivities. So therefore, the objectivities will include both performance and functionality objectivity. Also, we need to look into documenting the database and the design, which is useful to ensure that the organizational schema, data object, and the other related information are now captured for future reference. So this business process will now make it easier for the company to have really structured databases, and it will be easier for them to extract information due to the fact that now the business intelligence process has been carried out effectively. So different type of database documentation will now include the architecture, database development, administration, production support staff, and quality assurance staff. Now we have to look into what is a data dictionary, which is by data dictionary is all about the data and that we've stored into the database, and is going to contain all the information about our data objects, which is like storing all up-to-date information about the objects such as table, columns, index, contrasting functions. So what we can see below is a sample data dictionary view of table. And now we can look into what are the advantages and disadvantages for using them. So for the advantages, we can now see the well-structured and clear information about our database. So anyone can now analyze the requirements, any redundancy like duplicated columns, and etc. So this data dictionary can now help user by providing the details which are within it. But the disadvantages is that it should be well designed in advance to take all the advantages on it. and the cost of data dictionary will be hit high, as it include an initial build and hardware changes, as well as cost of maintenance. So due to the fact that it's a pretty much structured work, you now require people to be able to commit less error possible in order for us to not have to troubleshoot or constantly work to improve the database system. Also, there are database evaluation, where it just include performing data validity, data integrity testing, and performance, where they now check the database and test the efficiency. So when it comes to this evaluation, you have to look into testing, and there are different types of testing, such as structural database testing, functional testing, and non-functional testing. All this testing can now be carried out on our schema, or even our mapping testing. So by mapping testing, we just create a roadmap, a flow chart of how we're going to carry out these tests, which are going to involve validating the object on the front-end application with the database object mapping. So as we can see, for example, Microsoft SQL Server, which is a tester that can write simple query to check and validate schema in the database. Also, now we have to look into storage procedures and the view testing, where they're going to ensure that this will enable the required triggers to be executed and expected. While when you have to understand what trigger testing is simply ensure whether the coding convention are followed during the coding phase of the trigger. So all these concepts are pretty much related to testing and how these are important for us. So Adrian, I just want to understand from you, did you manage to create a simple table like this one here?
Yeah.
Okay. What you have to understand is whenever it comes to when it comes to work with databases and use structured query language to manipulate data, it's really important to have these ERD tables, which will allow you to understand what are the procedures and how is best for you to extract the data, and which tables you have to look into in order for you to work with SQL. So MySQL is a software which will allow you to, once you have created your tables, you can now work with these softwares such as MySQL. Try free. Let's see if I can download. Let me see if you have to pay for this. Oh yeah. So MySQL is connected to Oracle. Sure. and it's certified by ED. So I've never worked with this one yet, but I recommend to use Oracle one, which is pretty much easier to do some to query the data. So this is everything for today's session. Is there any question for me?
Is the Oracle one paid? You have to pay for it.
Yeah, they paid. Yeah. Do not sign in for that. Just go on Oracle. On Oracle, there's a database management system. That one you just need to sign in with your email address. It's free. So if you want to sign in on them, can you see my screen?
Yeah.
Yeah, if you go on database service. Oh, hold on. For database. Yeah, I'm not gonna sign in here because it's not my account. But I recommend you just to sign in, and this is where you can now start working with SQL and do some basic coding. So is there any question for me?
No.
Okay. So next session, we're going to have our assignment discussion. And this is everything for today. So did you manage to create the table? To create a simple table with
Yeah.
you? Huh?
Yeah. Yep.
Okay, very good. Okay, thank you very much for joining, and I'll see you tomorrow.
Yeah. See you tomorrow.
Bye.
Bye.